Okay.
Nothing from my side.
So from your perspective, Holger, there is nothing that needs to go in that is glaringly missing for a newer release. Again, it doesn't have to be tied with Volta, but I think we have done pretty good work, and it's a pretty good cadence to keep it 3 months for now. So I think we can stick with that. But you guys are not seeing any major issue with the latest updates?
No.
Okay, and Chandra, you were also mentioning that you as well, with the implementation that you are doing, are not seeing any major issue?
I would like to discuss on the design that we are thinking through and receive the inputs from the community. Maybe if I can get some time, I just want to present the design and also discuss the progress that we are making in this forum.
Absolutely, absolutely. I have a bullet for you in here to do later. But I just wanted to make sure we're not missing anything major that needs to be worked on in the upcoming month.
Perhaps just one thing. I mean, the version number we are currently using, I think we're currently at 0.10.2. I don't know if you're using versions for the protobufs as well for others which are not aligned to the Volta numbers. Yeah, exactly. This is a question I have. Should we try to get to a major release?
Yeah, my idea was to get to the major release when we had the certification, at least for one of the OLTs done, meaning your OLT. At least working, making sure at the ONF side that is working on hardware. Thoughts? Maybe we will do that. And again, it doesn't have to be tied with Volta, so it might happen at a later point in time. It's just a minor, it's just a version change. But yeah, that's a thought that we can have. Maybe let's discuss a little bit further down in March if we can do that or not, depending also on how's the testing going.
How do you version your other interfaces, like the other gRPCs you're using within Volta?
There is everybody goes with his own version that they would like and prefer. So there is no tie to the release name. Also because we're not really tying the DMI to Volta at all. So we can go with whatever we want. That's what I'm saying.
Okay.
When do we do the 1.0 is totally up to us, and it's totally up to everybody within the group that is building something that needs to get released when they do the 1.0. So it's just up to us. It's our decision. We could do it. I don't see any major issue in doing it. I'd still like the hardware testing in.
Okay.
Okay. So having effectively all these done, Chandra, do you want to present what you guys are up to and the questions you had?
Sure, Andrea. Thanks. With your permission, can I share my screen?
Yes, please. Let me stop sharing mine.
I hope you are able to see the Word document I am presenting.
Yep.
Yes, we can.
So this is the high-level design document we tried to put up and some levels of details into low-level design. First, I would like to just go through this OpenDM agent overview, the components view of it. On the northbound, it implements the device management interface. that is gRPC protocol for all the procedure executions, hardware, software, metrics, and event, and all the events metrics published on the gRPC proto format. We are yet to decide whether it's on Kafka or gRPC streams, but we are just stopping at this point wherein we are encoding, and once this decision is made, we will continue on this. For now, we are just focusing on the gRPC procedure executions. And feel free to stop me if you have any questions. So this is a gRPC server. We want to implement the DMI, and the business logic of DMI resides in this service, DMI RPCs. That will coordinate with the device configuration management, all the NEM on northbound configuration, and the device inventory and the context cache management, and a service for handling the asynchronous events like Sfp inserted or Sfp removed, and also collecting the metrics, CPU, memory, disk, and all the resource KPIs, and interfacing with a software upgrade application, which is responsible for managing the disk partitions, the active on standby, and also the grub configurations. And for events and metrics, we are planning to use the standard Linux commands and the ONLP APIs for the events and metrics. Mainly the EPROMs, EPROM registers will read for all the states. And the hardware that we would like to monitor components are CPU, memory, disk, fan, power supply unit, NI and PON transceivers, and the temperature sensors. Any questions or inputs on this architecture? This will be the sole basis for our code organization and the services that will be defined.
From my point of view, this looks good. I don't see any major issues with it. It's totally fine by me. Anybody else? Has any thoughts? Looks good.
Okay. Thank you. But if there are questions, we can discuss on the way. So coming to some more details, we are thinking we will go with C++ as the programming language for the implementation. Any inputs or recommendations on this? We want to adopt more of the proven thing what we have on the OpenVolt agent on the high level design as well as the programming structure. Mostly we would like to employ the same design here. And right now we are just working in implementing a sample gRPC, that is start managing the device as of today in the current sprint. First target we have set ourselves is to have a make file and the README, and doing the C++ based gRPC server code auto generation. In the community GitHub repository, we see that there are Golang and Python files already checked in. Now for C++, I wanted your guidance whether we should check in the auto-generated code or let it be in the OpenDM agent code base. Only the protocol will be referred from the DMI.
So from my point of view, if it lives in the library, it's better because it's tied with the library itself. That should be pretty straightforward to generate the code whenever a commit is made. You would have a new make protos target with just now we have the Golang in the Python version. You could just add the C++ one and check it in. So my take is, yeah, create a make file target and put it into the code base. So it lives.
You're talking about put it in with the rest of the checked in code base stuff, right? You're not talking about just in their implementation. You're putting in the protolib area.
Yeah.
Yes.
I'm saying put it into the existing
Yeah.
device management interface GitHub repo.
Yep. Makes sense. Thanks.
Okay, thanks a lot. Then the next point is on the gRPC server, basically the threading model. So we think that on every gRPC procedure that is invoked, we will handle it in a new thread. So we want to use the C++ gRPC library. So it default provides the new thread spawned for every RPC invoked.
Is there a limit to that? If you're spawning a new thread on every gRPC, that seems to open itself up for some sort of DD, denial of service attack. If something bombards it with gRPC, it's going to create a bunch of threads and bring down the system.
Yeah, more of a thread pool might be easier to manage and load balance.
Yeah, I would agree that a fixed thread pool might be a good idea.
I think when you start the gRPC server, you have an option of specifying the maximum number of threads that it could create. It has a default value, and then you could change that.
Oh.
Yeah, but it's not unlimited.
And when we hit when you hit the maximum, it just starts blocking until a thread opens.
Yes, yeah. It just stops creating anymore.
Okay, that's fine. As long as you can set some sort of maximum, then it's doing queuing in.
Thanks a lot. So we will use that max thread configuration in order to limit ourselves. And just getting to understand the continuous integration and the Jenkins from the OpenOLT agent with respect to the OpenDM agent, what we need to bring in here. And on the client session, should we limit ourselves to single client, or the server should be able to manage any number of clients?
My thought on the client is certainly you could start with one, but what is the big difference between like if you lock the operations, meaning you don't accept the same call getting called twice, or if it's already in progress, what's the difference between having one or many clients?
As such, I don't see any problem, but yeah, just wanted thought. So we need not limit the number of client sessions, is what you're saying.
I mean,
as we don't.
If it's easier for you to limit to one at the beginning, why not? But my take is that there shouldn't be any issue in not limiting that one.
I would almost think you'd have to do more work to limit it than.
Yeah, exactly. I mean, you just open a gRPC server and whoever connects, and it's up to you not to mess up the consistency of your internal state, but that's independent of who calls it. If you receive the call twice, even from the same client, you need to make sure that it doesn't mess up everything. So.
Okay, understood. So the implementation should take care when one procedure is ongoing, if other procedure should be blocked, so that should be anyway taken care. So allowing the number of client sessions should not be of concern. Okay. On the continuous,
I think you're talking about data consistency and data protection from current access, and yeah, you have to take care of that. Is that what you're asking?
yes, that is one part of it, the data protection when there are simultaneous updates on the same.
All right, thanks.
I didn't get your question on Jenkins. What's that one?
There is no question. This is just that we are just grouping and understanding the continuous integration requirement by referring to the OpenOLT agent. How we enable the continuous integration.
Okay.
Just understand so that I can contribute to the community.
Yeah. So
any guidelines or any inputs, if we have, we would like to know on this.
Yeah, so well, not an issue, but the thing there is that you kind of need two things, like per patch set validation, that we need to understand what we want to do, and also a hardware validation. So the hardware validation would probably be done on top of your OLT whenever that comes in, or Edge Core OLT, and we can set up something on a nightly basis whenever we have it ready. And that's one thing. The per patch set validation, I wouldn't do it. I wouldn't do it in on the hardware, because that would require building, redeploying on hardware, and our hardware pods are somewhat limited in our resources. So I'm not sure. Per patch set validation might just be compliance with the interface in terms of like static checks and linting and things like that. Functionality checking might be reverted to physical pod in the night or something like that. Does anybody have any thoughts here?
I think you're going to be limited to unit test, version of the version tick check that we're doing everything else. I think that's all triggered by makefile targets in the current Jenkins jobs. Is that accurate?
Yep.
So it might be that they have to implement some standard makefile targets to easily integrate into the existing Jenkins per patch stuff.
Yeah, I agree with David. It should be a makefile target that invokes the unit test of the class and the
Linting. I mean, we do linting, we do formatting, some other tests, right?
all that stuff. Yes.
Sure. Thanks.
The one thing that's going to have to be checked is if our build servers have the appropriate G++ or C++ compiler that you're requiring.
That's a good point, David. Thanks for bringing that up.
Yes, I think we will work on the comprehensive documentation of README, wherein we'll document all the necessary APT packages and the build environment and the make targets.
Yep.
Okay, sure. Thanks.
Because are we building in Docker? And if we are, you know what I mean? Building, if the Jenkins tests are compiled Golang via a Docker container, then we're gonna have to make sure we have that runner for Jenkins as well for C++.
Okay, Docker runner for C++.
Yeah, I don't know if we're using Docker runners or what we're using for Jenkins jobs, but if we are, we just gotta make sure it's compatible with what you guys do.
Okay, so scheduling this build job on a Docker environment is what you're saying, and clean it up when the build is done, the Docker cleanup?
No. It's so the Jenkins build servers, they have what they call runners to execute the steps. And the runner has to have all the tools required to build test your project. And we have runners that we know work with Python and Golang. We just have to make sure we have a runner that works with C++.
I think we do, David, because the OpenOLT agent is written in C++.
Okay.
So maybe this is just a matter of us internally at ONF making sure that the infrastructure is there. I don't think this should be an issue on the Radisys folks.
As long as the compiler versions are the same, yeah, it should be fine.
Indeed.
So Andrea, if I understand correctly, the runner environment is taken care by community, and all we need to provide is the source code, and it will compile, and the binary will be generated. And any unit testing also will be executed using the make targets in that runner environment.
Yes, you're correct.
And just a thought, the complete building of this binary and unit test, is it done in a Docker environment or is it on the host VM?
Usually in a Docker environment, so we can sanitize the image that builds this and make sure that all the versions are properly set and all of that. So it's usually in a Docker environment, but maybe take a note in this document. Can you share the document after the call?
Sure, sure.
Maybe take a note on this that I will have to check with the guys at ONF how we do for the OpenOLT agent, because this reminds me a lot of the OpenOLT agent, and I just want to make sure that we are kind of following in the same footsteps without messing, without changing too much of the existing stuff for C++.
So with your permission, I have put your name here. Sorry.
Yep. Perfect.
Okay. On the next thing, the definition of the file structure and the file functionality, we are largely following this. That means each of these components will be a C++ class. They implement the methods and they will have a data context within. Like there will be data, the context plus the methods bind to each class. So everything will be a class implementation in C++ for each different functionality.
Yeah, that's fun by me.
Yes, something of this sort we are thinking. I'll just publish the headers and the application code for the event management hardware metrics, server, software, and common utilities, and the main file.
Yep.
And as I mentioned, like whenever a gRPC procedure is invoked, it will result in a thread being created for each of the RPCs, and that thread will have to access the class methods of different services.
Makes sense.
There can be multiple parallel threads running and accessing the context. We see that there is some need for having thread synchronization using locks.
It really,
and we plan to use yeah, sorry.
so on that, it really depends on what you're accessing and what type of operations you're doing. To me, on a read, there is really no issue. On a read,
That's not necessarily true. If you're reading data that's being written at the same time, there's a concurrency issue around that memory space.
yeah. Okay, yes. But
So there's a read lock versus a write lock, I agree, but still have to watch out.
Well, but if you're reading from ONL or ONLP or things like that, I assume that the platform itself protects against concurrent data access.
If you're calling a system library,
Yeah.
I would read the documentation on the system API. I would not assume all system APIs are multi-thread support.
Okay. But yes, some synchronization is needed for resources that are commonly accessed read or write.
Sure. Like we'll take a guideline that will be very judicial in introducing locks only if really necessary. Yeah. And next one, in the last community meeting, I had a question whether device should persist the northbound configurations. I think Holger mentioned that their implementation has the persistency. So just a recommendation I need, Is it fine to have like Redis or MongoDB, or any pitfalls or any suggestions here on the persistent storage?
First, just perhaps one comment. While we're using a database, I mean, we have a different architecture because our device manager is running off the box, right? And it is managing a lot of devices. The one you're talking about is running on the box, and I'm not sure, isn't there a device manager off the box as well, which could perhaps handle the persistent storage? I don't know. I mean, currently we're doing the way that the device manager off the box has a persistent storage, but we're not using persistent storage on the device. So if a device reboots, the device manager always reconfigures everything currently. So in this case, there's no need for a database system on the device. I'm not sure how, if your northbound system is doing persistency or could do it for you.
That was my understanding as well last time, that we decided not to have persistent storage on the device itself, but keep it in outside the world.
Sure. On the persistent storage.
Sorry, maybe I'm missing something here. So what does that mean? So if I take an example, right, say we configured the log levels, and after that the device rebooted. So is the expectation that after the device reboots, the name has to configure the log levels again?
No, the device manager is, I mean, for our case, the device manager is configuring the log levels again. So you're not
correct.
seeing
But in this case, there is no device manager, right? So in this case, I think the box has to store it in its persistent storage, right? This information.
Yeah, I wasn't sure because there was something. If you go up and go to the image again, wasn't there a device manager mentioned on top? Or what is it?
Nem/device manager.
Okay, so this is nem, not a device manager.
Yeah. I mean, it's their implementation. They can do whatever they want in some respect. Just it's yet another deployment issue anytime you add another database in a different location.
So given that we are on the device, do we really need a database? Can we just not write to a file?
Yeah, sounds. I mean, these are really only some hundreds, I don't know, bytes of data or so you have to store.
Yeah.
Again, I don't know what they're storing or what their data model is around it. I don't know if a simple config file's easier, right? Almost an init file might be easier than a database, but I don't know what they're doing. So I mean, if you're using a config file and you're updating it via the API, then you have to manage locks around reads and writes to the file too.
Yes, I do agree. We can write a structure encoded into a file, and using the stream APIs, it's possible. We can have a flat file storing the configuration, and you have the necessary markers for reading it. Yeah, possible.
Looks to me as simpler on the device itself than a full-blown Redis or MongoDB implementation.
Yeah, also, it might be better to write it into files because when we want to do a software upgrade and we would want to persist this configuration across the upgrades, handling files might be easier than taking the configuration out of a database and again putting it into another database and things like that.
Yeah.
Agreed on it. Agreed. Even if we have these databases, again, we have to take a snapshot and export into a file again. Like
Just
again,
remember, you're going to have concurrent access issues around the file, both reading and writing. And so you just got to protect that in your code.
Yeah,
agree completely.
Yeah, some protection against reading and writing of configuration data, yes, is needed. but I still do believe that a file is better than a full-blown database, especially given that it's, again, probably a couple hundred parameters, worst case that we were writing down.
If it's config information, I'd agree. I mean, I don't know if they're going to start doing queries against this data or not, right? Or how big this data is.
I would advise against
If
query
it's,
data.
I mean, if it's log levels, I absolutely agree, that type of thing, configuration data. But if it's something else, again, I don't know what it is. At some level, the flat file is not as easy as a real database. I would hope you don't need that on this, but you don't know. I don't know.
No, I see your point, David. I see your point.
Yeah, in a way, like Redis DB will help us out with a KV store and designated database paths to store various parent and child components. It's more organized and easy to access. And, yeah.
It's really hard to say until we know exactly what your data model is on the persistence, right? If it's very limited data, like was mentioned, log file configuration, what port to contact, that type of thing. A flat file is a lot easier and a lot less complex in terms of deployment. But if you're doing a complex data model, I think there's two questions. One is why, and two, then yeah, you got to look at what's the appropriate database to manage that. But I would resist putting a database on the device if possible, unless there's an actual need.
Sure. So then we'll first come up with all the configuration data that need to be stored. Then we'll get an idea whether to make the decision further. We'll evaluate on both of these.
Makes sense.
Yep, sounds good.
Yeah, thanks a lot on the inputs. And for periodic polling of metrics, basically running the Linux commands and getting the metrics and the 1LP APIs, we want to have a timer-based implementation based on the interval set by the northbound components. It will be a periodic timer expiry and polling of metrics. Any thoughts or inputs here?
The timer is being initiated from northbound, or is it in the agent itself?
Yeah, when the component is being monitored from northbound using the procedures, then the timers will be implicitly initiated on the device. No control externally, but yeah, when the API is executed for monitoring a particular sensor or metrics, the timer will be spawned internally. And the question is, you can set the interval separately for each hardware component, the interval for reporting the metrics. As there are numerous components, any thoughts on managing the timers? Can we have single timer or multiple timers?
One timer per element, is that too much?
Does this get into the question of multiple clients? Then if I have one client that wants to monitor 5 minutes, and one client wants to monitor 10 minutes or 8 minutes.
No, this isn't possible. So
it's not possible, or the API doesn't allow it, or what?
Yeah, the latter one. So you do not, there's not a configuration per client. There's only one configuration per device manager or per server or whatever. So
all right.
Per object.
So so if one client sets one element and the other one sets the same element, then the last one just wins.
Okay. Thanks.
But I think in principle, you can have a timer for every, you can have different timers for every of these metric elements which are then pushed. So yeah, it's one timer per element.
Yeah, okay. So per metric, you could have a timer, right? So you could say that, okay, give me the CPU usage every whatever 30 seconds, but give me the say RAM usage every 1 minute, and so on, right? So, but Chandra, I think this is a very low-level implementation detail, right? So it would depend upon a lot of factors, right? The language
Yes.
that you're using, how easy it is used to like create timers, and what kind of scale you could do with that. I think you can take into account those things, and whether you want to do a timer queue or you want to just spin off a timer every time you get a request.
Okay.
I think you have a multitude of
I think
options.
we'll. Okay. Yeah.
By the way, I think we are only supporting timers from, I don't remember, perhaps from a minute or so upwards. So you cannot specify like millisecond timers or something. So I guess you should do the same. I mean,
Yeah, that makes sense.
yeah. I mean, in general, for our products, timers are like 15 minutes intervals and then 24 hours intervals or something. So I do not see the need to specify them in seconds, or I guess minutes also should be enough, which makes your timer implementation much easier.
In minutes granularity. Yeah, largely.
Yeah, I don't know. Yeah, but I just wanted to say you don't need 1 second or few. I'm not sure what the interval is actually, if it's seconds or perhaps Amit knows.
No, I don't have a number either. But yeah, I think you should go to the granularity that can be supported by the device. And as long as you are adhering to the interface in saying that, okay, invalid parameter, right? If a value is given which you don't support, then I think it should be fine, right? So even if you don't support it, it can be figured out during the tests, and appropriate actions can be taken.
Sure, Amit. Understood. But largely, like we have seen requirements from operators saying that every 15 minutes or every 1 hour or every 1 day. So yeah, just was we're thinking whether seconds level or like granularity is really required. Yeah. But yeah, device should be able to support in seconds. Agree. Next one is regarding the SFP events. Largely, we are relying on the EEPROM register access through NLP APIs for SFP reboot and inserted. So right now, we have come across in prototype. It is based on the frequent polling and not a callback whenever the event actually happens. That means we need to frequently poll to identify that there was an event happened, either SFP removed or inserted. Any thoughts or any alternatives here? Like polling mechanism to detect an event, hardware event.
Is that really it? I mean, ONLP does not have the capability to detect if the transceiver is plugged in or plugged out. That seems strange.
Yeah, no callback. Like the register value will be updated, but you need to poll on it to understand whether SFP was removed or inserted.
Okay, let me.
That seems a poor mechanism, because if you're going to spend all your time polling, that's eating a lot of cycles.
Yeah, that looks not right. Put an action item on myself, please, here. Let me check internally at ONF with people that have used ONLP about this, and maybe there's a smart way to do it that we just need to figure out and use, or something like that, you know.
Yeah, it seems like there'd be a way to monitor I2C bus.
Sure. Yeah, I think this one we discussed. For CPU memory disk, we'll go with standard utilities for fan, PSU, and temperature sensors, ONLP APIs. And regarding temperature, what we come across is there can be devices with multiple temperature sensors. We should be able to manage each of the sensor setting the threshold to report alarm, and there should be some component ID that will be like associated with it. And similarly, power supply also, there can be multiple power feeds, DC power feeds, and fans also, there can be multiple fan units. And the next item is on the gRPC security. Should we like take it on a lower priority, or should we start with a certificate-based authentication between the client and server, or we can take it in the next releases?
Volt is at 2.7, still hasn't dealt with security certs, which tells me if you don't do it now, like it won't be done for a long time. But Volt itself lacks this as well.
That's a good point. So there's a few issues here. Well, not really, but what I would suggest is on your end, start with putting the certificate in a well-known location. And if it's there, start the secure gRPC on that certificate. If it's not there in that location, just start a non-secure connect server.
I mean, I suspect audits important in this type of stuff, as it should be the Volta too, right? You want traceability of who changed what.
Yeah.
And if a change to your device has potential customer impact, then you want to be able to have that audit trail.
Sure. Thanks a lot. So we are just thinking of using OpenSSL Gen to generate the certificates. And primarily, you need to configure with some domain and details in order to create the certificate for server and client. Then we will just host those certificate in the repo for everyone's use, and then using that we'll validate.
When you do certs, right, you're going to want to follow the model of Kubernetes and kubectl, right? You can have multiple certificates used. Each user could potentially have its own certificate. So these aren't certificates that are baked into the server side. They're somehow configured to the server, who has access. So yeah, that's to say, don't hard code the server side certificate.
Yes. So server, when it is instantiated, it will look for certificate. If available, it will start with secured. Otherwise, it will fall back to unsecured.
Okay, and it might be, you might, it's not looking for a single certificate. It's looking for multiple certificates. And eventually, when you get to RBAC, each one of those certificates might have a different role associated with it, and therefore different permissions.
You still need a place to load those certificates in, right, David?
You need a way to load them in, yes. But yeah, just as you go through here, just I would think about the final model of security and keep that in mind.
Indeed.
Sure. Yeah. These were the points that I just wanted to discuss and get your inputs. Thanks a lot for a healthy discussion. I'll share this document. In the subsequent sections, I try to put together something that OpenDM agent should do as defined in the DMI interface from the device perspective, what can be done. And just one other thought, do we also consider rollback to the factory default after like factory default image and rolling back to it when you are neither able to boot from the active or standby partition? Any thoughts on this?
I am fine with that, but I have close to zero experience on the hardware, so I'd like also other folks to comment.
I'm sorry, I missed the comment.
The question is, can we provide, do we want to provide a capability to revert to standard factory settings if everything goes wrong?
That's not a bad plan.
I agree, exactly.
Sure, we'll come back with the proposal on how we can have this logic on falling back to a factory default.
Yep.
Sure, thanks. Yeah, thanks a lot, Andrea, for the slot to share this.
No, it's
Thank you.
really good details, and I think getting a second and more close to the hardware implementation is very interesting. Okay. Anything else that you guys want to bring up? Because my topics for the day were finished. I don't have anything else, but I'm happy to take any of the comments you guys want to discuss before we break for the day. Okay, then if not, if there's anything else, I'll share the recording and I'll talk to you in a couple of weeks. And in the meantime, let's make sure that everything is ready as we want it for the release that we might want to make within the Volta timeframe. But apart from that, I think we are in pretty good shape. So thanks everybody and have a great day. Bye-bye.
Thanks. Bye.
Thanks, everyone.
Bye, guys.